Thank you so much for being here with us at Time Machine. These are two very special days of the year for us when we take ideas and work and partnerships and all of the investments that we make in making AI real with our partners and our friends and get an opportunity to showcase and share these with you. So these are very meaningful days, and your participation means a lot to us. So again, thank you very much for being here with us. You know, um, Before I get into my talk, which this year I chose a very practical subject, and I'll tell you why I chose such a practical subject to close out Time Machine here in a second. But before I get into that, I'd like to share something with you, which is that my fundamental belief for a while has been that if you truly step back and you look at the nature of the human condition, I believe that all human beings are equal. And so the way that I explain that is to say that if you took 100 people from the US or from Australia or from parts of Africa or Asia or wherever, and you put them under the same circumstances of stress or of plenty, over time, statistically, you would expect behaviors from the group that would be about equivalent. And that's what I mean when I say I believe all human beings are equal. It's not that any one person can't be a standout. Of course, that can happen. But on the whole, people are about the same. And if you read history, and if you really look at the reasons why at many times in the past, we've allowed our societies to fall into disrepair and we have become despondent about the future. It's mainly when, under conditions of stress, we act out not with our better instincts, but with perhaps those demons that each one of us carry inside of us as part of that human condition. And that creates this sort of stress and ugliness in society, which is captured in the pages of history. So as I read through all of this, and this is sort of a summary of human history almost, and as I thought about, well, what is that one element, that one lever, that one change that can be made to write a better future, write a history that in the future would be looked at as a kinder history, as a history of greater human success. And what I felt was that the role that technology has played through history is one of a stress reliever in the most part, where it has allowed us access to food, it has allowed us access to medicine, it has allowed us access to security, and it has been a damper, it has been one of those things that has curbed the negative parts of the human instinct. That is my understanding of technology. That is my belief in technology. It is a belief not in the abstract, but a belief in an instrument that can lead to a brighter future and to a more pleasant history that perhaps our descendants will have the pleasure of reading one day. Now, with that, you'll see that as I walk into and I talk about the rest of my slides here, these are very, very practical matters. Over the last year or so, we have engaged with large companies. We had the privilege here of having Boeing and Ford and Mitsui and so many of our partners from across the world, and Newland Group from China. And these are all partners with whom we are doing significant projects, significant deployments that are changing the world, with Aker BP as an example. And so in all of these interactions, we've learned very important lessons. Today, as I interact with leaders in enterprise, one of the biggest questions that comes up is, how do we go about implementing AI? This thing that you call AI, first of all, what is AI? Is AI a product? Is it a thing? Is it something that I can buy and install on my computer? What is AI? And I always say, look, AI is like mathematics. It's like physics. It's a science. It's not a product. It's a way of thinking. It's a science that can be used to implement so many capabilities. Professor Porter yesterday so ably explained to all of us that machine learning, which is a branch of artificial intelligence, is really only focused on identifying correlations. With a simple thing like that, identifying correlations, so much magic, abounds from that basic characteristic. I'll share with you some examples of that. But today my talk is devoted to something that I call the model-based enterprise. These are lessons that we've learned in working with the largest companies in the world, with Verizon and with Boeing and with State Street and truly Ford, the largest companies in the world. How do you implement AI in your enterprise? How should you think about this? Well, the first thing as a motivation, people tell you that AI will change the world. Nothing will be the same anymore. AI has tremendous promise. There's also some of the negative thoughts that people have, that AI will change warfare and autonomous weapons will run amok and that jobs will be lost. But the reality is, if you look at McKinsey, you look at Accenture, you look at the World Bank, you look at almost any organization of repute that deals with these issues, you'll find that indeed the impact of AI is, first of all, horizontal. It applies to all industries, not just one or two. So again, it's a science. It's like math. It applies to everything. And secondly, the quantum or the magnitude of that impact is unignorable. So I'm not going to read these numbers, but that slide or that section of the slide on the right really tells you the degree to which relatively near-term improvements in profitability can come about across all of these sectors. These are massive numbers. It changes the world. It changes the world in a way that if you think about food service, for example, becoming so much more efficient that profitability goes up by 74%, we're feeding the world through technology already. The issue is not one of not having the resource. The issue is one of distribution. And these are the types of things that the onset of AI will now force us to ask these questions. Do we now have enough food in the world to feed everyone? Do we have enough energy in the world to provide everybody with watts per capita that can lead to a decent life? In many cases, you'll find that with applications of AI, the answer will be yes. So then what is the question? The question is, will we make the choice to build a world that allows everyone access to these opportunities that AI creates? Now, let me take the idea that Professor Porter presented yesterday one step further. What Professor Porter said was that really machine learning is about correlations. And artificial intelligence in general, the way that I think about it, when you implement artificial intelligence, you're really talking about four things. You're talking about perception. I'll give you some examples of perception. But for example, we see with our eyes, I see here, for example, an audience in front of me, and I see the shapes of individual heads, and I can make out individual people. That is perception. The second is a decision-making process. The decision-making process is one level deeper. It's after I enumerate all of these objects, after I perceive everything in terms of auditory input and visual input, etc., what do I need to do in this situation? What is my decision-making process? And the decision-making process can draw not only on that which I perceive in the moment, but also on past knowledge and experience and so on and so forth. So you can see that qualitatively, decision-making is a different thing. It's not just perception. The third thing is that once we perceive a situation and objects and our environment, and then we also decide what it is that we want to do, then we must take some action. And that action also requires intelligence, and that action can be thought of as a loop, because as you are taking action, you can continue to break that up into smaller and smaller steps, and generally step one then requires some adjustment, and then you take step two and so on. So action is complex, and it's a distinct thing. And fourth is learning. Every time you perceive, decide, and act, there is an outcome. And you need to capture that outcome. It's another form of perception. It's the perception of an outcome which leads to experience. And drawing upon experience leads to learning. And then repeating this loop again means that as the Japanese refer to it, the process of kaizen or continuous improvement, right? So these are the things that you get when you implement automation with artificial intelligence. Now, Professor Porter is absolutely correct in that the Lego blocks, if you will, that make up each part of this construct before you, those Lego blocks are nothing more than perception. But to me, that's actually a correlation. But to me, that's actually a very beautiful result. Because it's sort of like what happens in nature. Simplicity gives rise to a lot of complexity. And it's a question of abstraction. How will this value be realized? So I explained to you that I look at AI in these 4 ways. And I look at the application of these algorithms that deliver correlation packaged in these 4 ways. How will we realize this value? So, for example, take the financial industry, the military industry, and the utility industry, electric power distribution and generation. And let's ask ourselves, well, what is this perception and decision and action? What does this look like in each one of these industries? So, examples of perception or perceiving, in the case of, the first industry, it might be you look at a customer, you recognize their face, or perhaps you recognize their handwriting, and you might also have some natural language understanding. So it's not just that you're identifying the handwriting, but you're also sort of understanding what words were written on an application, as an example. In the case of a military application, you might have an aerial vehicle, a drone, with an ISR or a surveillance system that is looking at objects, and it just detects the object. So the first step in perception is look at that video feed, look at those images, and just identify for me what objects this particular frame actually contains. Perception. And then in the industrial case, you have vibration sensors and temperature sensors and other forms of inputs that are coming from industrial equipment, pumps and rotating equipment and compressors and turbines. And this is another form of input that we can perceive, and we want to then detect the state that the equipment is in. Is it on? Is it off? Is it running at full power? Is it optimally efficient? Now, what are examples of decision that get tied in with this type of perception? One example would be somebody's written out a loan application with their handwriting. You've been able to perceive or identify their face, and you want to automate the process of loan approval. So the decision in this case is, do I approve or deny a loan? There are now machine learning techniques, for example, that can even pick up changes in your expression as a measure of whether or not it's likely that you are lying. So a system like this can automate the process of asking you a question, continually looking at your face, and then correlating it with the face of a liar or of somebody that's telling the truth. And again, so from that little correlation capability, you get the ability to decide whether or not you want to approve or deny the loan. As one input, you might have many other inputs as well. Now that you've, in the military sphere, detected objects, the question is, should I target them or not? And there's a very common misconception. People think that, if I get an image and there's a tank, for example, it's a tank, so I must target it. That's not how targeting works. There's a whole set of rules that must be met or fulfilled. There are the laws of armed conflict, for example, that must be followed. There is positive ID that must be validated on this object. So you get into complex things like the pattern of life around an object, the detection of an object, the perception of an object, and the tracking of that object through time in order to validate a hypothesis about that object. This is a complex activity. AI systems are able to do this today. In fact, SparkCognition has done some work in areas like this. And so the decision making then is, should you target or should you not? And the case in our industrial scenario is, now that I've read those vibration sensors, now that I've kind of built up a picture of what state this turbine is in, now I've got to make a prediction. This prediction is, will this turbine fail? Will this pump fail? And by the way, what kind of failure will it experience, and when will this failure occur? So I've given you examples of 3 different domains. And across these 3 different domains, I've shown you how perception and decision can really get you to actually automating part of a task. And the final part of this is, of course, taking the action. So now that you've looked at that handwritten application and you've asked a bunch of questions, you've validated that this is indeed the person who's applying for the loan, you've determined that they aren't telling a lie, perhaps you issue them credit and you mail them a letter and then you create a physical account. You actually take action. In the case of the military, you might positively ID a target and then actually launch a projectile and guide it. And in the case of the industrial application, you might shut down the turbine or control power somehow or disconnect something. There's some physical action. But now think about what we just did. We described an entire business workflow in 3 different domains as a collection of perception, decision, and action tasks. We automated that which is done today by human beings in these areas, and by chaining these things together, which again, at the very low level, require nothing more than correlation-based machine learning, we just built a workflow. And that gets me to this idea of looking at our organizations, looking at our work, looking at our companies differently. When I talk about the model-driven enterprise, what I'm saying is that we look at the workflows that drive our companies. We look at breaking up those workflows into individual elements. Those individual elements are models. Again, a perception model, or a decision model, or an action model. And many of these can be chained together in workflows. So for example, you can build a pipeline with an AI system that evaluates and decides whether or not to hire a recruit, automatically sets the salary, creates an account in your HR system, and emails them a letter. The reverse of this, by the way, Amazon is doing already. They are firing people without any human intervention, purely driven by AI, where they observe performance, they make decisions, and they send a letter saying, you've been terminated. I think my example is a rosier example. Then you can, of course, identify a potential customer online. Imagine AI scouring the social airwaves and identifying potential customers online by doing natural language analysis, autonomously creating an offer using a technique called natural language generation, and then sending that offer out to the customer. If the customer buys, you've just created a virtual salesperson workflow. Okay, I'm breaking this down to this level of detail because I can tell you that these are all systems that we've either built or can build very, very easily with the capabilities that we already have in the products that we already ship. And the reason why I'm giving you these examples is to spur the thought in your own mind, in your schools, in your universities, in your manufacturing-oriented companies, in your banks, in your insurance companies, in the military. How can you think of the things you do and break them up into these pipelines that can then be composed with these models? So again, the model-driven enterprise is an entity that has much of its work carried out by these chains of AI-driven models, which are in turn made up of components that perceive, decide, act, or perceive, decide, perceive, decide, and act in any combination, right? And so you can take workflows at the factory, you can take supplier management workflows. Every time something comes in from a supplier, do an automatic quality check, visually do that quality check, and then tell me how this compares to another supplier that's doing roughly the same kind of shipment, and build a case autonomously for why I should go back and negotiate a better deal with supplier A. Totally doable. It's not being done with AI today, completely doable. So a lot of these types of workflows can be built with the AI systems of today. Again, in marketing, I gave an example. Sales, same thing. The model-driven enterprise is a bunch of these AI workflows running together in parallel at scale. So now imagine if you take, say, 80% of what a supplier management representative does, and you convert that into workflows. And now on a bigger system, you just want to scale up 1 million of those threads, 1 million of those processes. You suddenly have a company that has 1 million virtual workers. Think about that for a second. What I'm talking about is that when you move to a model like this, you can create scale and capability the likes of which has never existed on planet Earth. So, model-driven enterprises change the game. First of all, because these processes are digitized, they can be replicated. Like I said, you want 1 million marketing professionals, you want 2 million people doing sales price comparisons autonomously across the inventory of, say, the largest economy in the world in a particular category of product, no problem. If you've got the compute capacity, launch the AI pipelines that are running these models and you're in business. Learning is continuous because I explained to you that the last part of this loop is all about learning. So learning is continuous and these models are getting better and better and better over time. So it's the kind of employee, if you will, if you think of this workflow as an employee for a moment, it's the kind of employee that's teaching itself all the time, 24/7 and continuously getting better. And by the way, it's completely portable. So once you acquire the knowledge in one place, if you have an expert that really knows something, it's a subject matter expert type skill, and you have that person in Seattle, well, you can't have that person also in, Bonn or Paris. But with this, you can. You just copy them over and ship them to Bonn, and you can actually ship 11 of them to Bonn. It's a way of thinking about expertise packaged as AI models all chained together. It's the mental shift that when you truly start deeply getting into what these model-driven enterprises will look like, it truly blows your mind. Let's imagine now a world in which model-driven enterprises are a reality. So who wins in this world? What are the fundamental economics in this world of the model-driven enterprise? This model-driven enterprise that SparkCognition is working to enable. The fundamental economics are essentially the cost per model. Right, so I talked about, well, you can replicate this particular workflow and you can have 1,000 of these processes and you can ship 800 of them to Perth in Australia and have them run there. Yes, but what is the cost of doing that? And obviously, those who can do low-cost model creation and support win this game because they acquire scale. So that cost is made up of 3 things. The cost of creating the model, which today human data scientists, human PhDs in machine learning sit down with a problem, with a data set, they pore over it, and so that process is totally not scalable today. If I said go create 1 million models today at a large company, no company can do that because that process is manual and there aren't enough skilled people to do that in any reasonable period of time. The cost of model maintenance. In many cases, these models shift and drift. For financial market models, as the financial market underlying data signals shift, or for a physical piece of equipment, as that equipment wears and changes in its fundamental nature, the data changes. And so these models have to be retrained, redone, redesigned. Perhaps a different algorithm has to be chosen. So maintenance is another impediment in moving to this world of the model-driven enterprise. And finally, the cost of model execution, running these things. How much does that cost? So the competitor that dominates with the lowest cost per model just wins the game, completely wins the game. And I mean, I can imagine many sci-fi stories just based on this premise. Somebody that really cracks the code around model-driven enterprises is able to create, spawn, materialize these models, and overnight launches 5,000 of these models going and doing some economically viable activity, and in the morning wakes up and discovers that they've hit the jackpot. It's not really science fiction anymore. So how do we really impact this cost per model? SparkCognition has already imagined a world in which the dominant company is a model-driven enterprise. And we've said this in direct terms in the past as well, that there are 2 kinds of companies in the future. Companies that fully adopt artificial intelligence and companies that are dead. So that model-driven enterprise of the future that is driven by this fundamental economic metric of cost per model, what technology must that enterprise use in order to win this coming competitive battle? And that technology is what we call automated model building. By automating the process of building these models, by using genetic algorithms to evolve these models as opposed to requiring PhDs in machine learning and AI to sit down and hand code these models, by automating the process of maintaining these models, allowing these algorithms to automatically discover when the outcome from a model, when the prediction from a model, when the answer from a model is no longer accurate, and the model needs to be rebuilt and recreated and retrained, and the system just does that on its own. There isn't involvement of, again, a team of experts and a committee sitting down and making that decision. So these models can self-generate. These models can be autonomously tested. These models are self-maintaining. They are continuously improving. And they are, of course, replicable and transportable. By the way, if you use SparkCognition's Darwin system or the Darwin API, you have what you need to transform your business into a model-driven enterprise. In every regard, every element of what I've listed here is the vision behind Darwin. Will it become more powerful over time? Will it become easier to use over time? Will it integrate with more types of data sources over time? Yes. But we feel that we've already made a key contribution in opening the door to a new type of economy and opening the door to a new type of competitiveness that many in the industries that we serve haven't even truly fathomed the implications of. So my message here at this conference was really truly going to be that I think we're at the cusp of something fantastic, but no longer just in terms of hopes and dreams, no longer just in terms of theory, but in terms of a practical system that we've spent now half a dozen years building that leads to the kinds of capabilities that will give birth to the model-driven enterprises of the future. And today, I invite you to be part of this journey with us, this journey of transforming our companies of today or building new companies that don't yet exist on the paradigm of a model-driven enterprise. And the questions that I would have you ask yourself and your team members and your organizations is, what are these pipelines in your current workflow, the highest value pipelines that could be automated? Forget about the process in your company. What are such capabilities driven by these pipelines that you could embed in your products? What part of your product's function can be automated with these pipelines? How can you embed AI in your physical products? And how can you alter the fundamental economics of your business? For example, if your pumps and your turbines are maintaining themselves, do you no longer need to sell them as a fixed cost asset, a capital purchase? Can you now move to a pump as a service model and fundamentally alter the economics of your business? These are things to think about. This type of thinking leads not just to new functionality, but to new economics and new ways of monetizing your business. So how do you go about doing this? There are essentially a couple of really, really important things. First of all, in order to do something like this, you have to convince the leadership of your company, your CEO, your board, to put down this direction as a mandate and to say that we will do these things, not because, in the words of JFK, not because they are easy, but because they are hard, but they're worth doing. They are worth doing. And once that mandate comes down, there's essentially three ways in which companies deal with these problems, in our experience. Three ways. You'll have a business unit with its own technical capability, model one, work with a partner in a distributed way. And that generally is pretty quick. You'll have a business unit that says, not invented here, don't want to work with anybody, my data scientists will figure it all out. There's really 10,000 AI practitioners in the world that are high-end folks that can truly do things at architectural levels. And if you ask, say, an insurance company, how many of those 10,000 work with you, the answer will be hardly any. So that middle model for maybe very simple activities works, but if you're not partner-friendly, you're not going to get the best technology. That's just the reality of this game. This is a rare skill set. The third is where you have some centralized IT and analytics organization in your company, And you also work with partners, but IT has to be part of this mix. And in many large automotive companies and many large aerospace companies, this is what is happening. These are some of the benefits of doing it one way or another. If you have a centralized organization that's doing analytics, certainly you can standardize, and certainly the learnings can be internalized more easily because they go across project. But on the other hand, they're slower. Decentralized model is faster, it's easier to partner because there's a reduced number of stakeholders, and you can also have a solution-led mentality as opposed to an IT-led mentality. So these, in our experience, are some of those benefits. This is the sum total, in summary form of kind of what we've learned. If you want to go and reinvent your company as a model-driven enterprise, if you want to participate in this revolution, as your partner, one of the things that we've learned is that there's a number of practical things to keep in mind around data, around the fact that the project we choose can't be a toy project. Because a lot of times people say, okay, well, you know what, here's a toy project, first do this and then tell me how it goes. It's a waste of time for you and for your partner, because that is not a bridge, that is a pier. It is a set of activities and time spent in the pursuit of nothing. It's not worth doing. So you need to pick something that's worth it. Success needs to be very well defined. And then finally, with AI projects, it's not just about the 15% efficiency that you might get in iteration 1, but it's the long-term impact. Does this lead to a fundamental business redesign? Does this lead to new forms of revenue that I didn't think I would have access to, or opens up a market that I didn't think I could address? And then lastly, we work with large industrial clients that have been there for a long time. And in our view, our job is not to force everybody to become a software company, because that won't happen. Every company has a unique culture, and that culture, in many cases, defines success in that industry. So the purpose here is of software culture working with industrial culture, working in compatible ways and finding ways in which success can be delivered together. So thank you very much, and I hope you've enjoyed the conference. Very, very grateful for your participation once again, and I hope to see you all again next year. Thank you so much.